and welcome to the channel. It's been a while since I've done a talkie video, so bear with me. A few of you might remember that a couple of years ago I released a game called Perfection.
Oh, looks cute.
And it got great reviews. I absolutely adored watching people play the game.
Oh, that was awesome. That was really well done.
I was so very proud of it. Perfection had one massive problem. And ironically, that was how imperfectly the game ran.
So I don't know if it's just me, but like the controls are a little weird. Like it's laggy, is what I'm trying to say.
Looks really nice. It's a little bit laggy though, more laggy than I thought.
That looks like a potato.
Low frame rates really bogged down the game and left players unable to feel fully immersed in its narrative.
This place is not perfect!
So here I am, 3 years later, working as an associate technical designer, and I've decided to take a look at Perfection, see where I went wrong and how I can fix it. Today I'll share with you my top 10 tips for how I managed to get the game from running under 20 frames per second to at least 60 frames or more. I hope it can be helpful for you because performance is key. You can have an amazing game with great mechanics and a really intriguing narrative, but if it doesn't run, nobody can play and enjoy it. Number 1, Profiler. The first thing that you need to do is assess your full game's performance to identify the areas that need the most improvement. And that's where the profiler comes in handy. The profiler records multiple areas of your game's performance during runtime. This allows you to pinpoint where exactly your game is losing performance. On the left-hand side, there are separate profilers for CPU, GPU, memory, rendering, audio, physics, networking, and the top half of the profiler displays the overall usage. While you're playing your game, you can open the profiler and look for spikes in performance at runtime. And once you've identified these spikes, you can then stop at that frame and look at the bottom half of the profiler window, which displays detailed information from the currently selected profiler about the current frame of data. You can inspect script code, certain assets and resources that might be slowing it down. Basically, the profiler is the first thing that you should look at when looking to optimize your game's performance. Number 2, multiple cameras rendering. This might be specific to me, but this was the biggest problem that was affecting performance. I had multiple cameras rendering my scene, which meant I had multiplied the amount of draw calls that were even needed.
120. 15.
Now these cameras might be used for things that you wouldn't even expect would be hitting performance, such as reflections for materials, or a separate camera on your player for inspecting certain layers. However, if these are always on and never turned off when you don't need them, they are still rendering and you are still losing performance because of that. I personally had a security camera in one of my scenes and it was rendering all of the time regardless of whether the player was even within that room or not. To optimize this, I severely reduced the amount of frames per second that the camera would render, having it only render the camera when the specified amount of frames had elapsed within the update of a script that I'd put on the camera itself. And because this logic was running in the update, which means every frame, I put some checks in there first to check whether the game object itself was actually active and also to check whether the player themselves were actually facing the camera. Using the dot product method proved extremely useful when trying to up my game's performance, especially if the objects themselves had scripts that had logic running within the update. I will actually put a link to a video about how to use dot products in Unity in the description below. It's really useful. Check it out. One other thing that I did to improve performance was use collision boxes, which would turn the camera game object on or off depending on whether the player had entered or exited the collision area. Number 3, use layers. You can use layers for UI, raycast, or specifying what assets of a scene a camera can actually render. Alongside my security camera, I was also using some water for my terrain, which had a refractive material. By default, the material was set to reflect all layers of the scene, which was greatly impacting my performance. So what I did was I just duplicated the parts of the scene that I needed the water to reflect, and then set them to their own layer so that the player wouldn't see them, no other cameras would see them, they'd seem like they weren't there, but they were there specifically to be reflected by the water. This really helped performance. I used this for every single camera in my scene as well. They only rendered what I needed them to render and what was directly in front of them. Occlusion also does help with that though, but more on that later. Number 4, optimize your models. This is where I really struggled because I'm not a modeler, and yeah, I thought I would be doing mainly coding and scripting, which I enjoy doing, and then when I realized that I probably also need to update my models and make them more performant, I was like, but we did it, so let me tell you how. Multiple me's. Okay, so how I noticed that my scene and my models were probably causing me an issue was that I opened up the stats, which is at the top right of your editor. Opening this will show your frame rate, so it's really good to have open anyway, but also it shows you your tries and verts. And my tries and verts were bloody massive, just like huge numbers, and they still are, to be honest, because I didn't have time to and the knowledge to remodel everything. So that was a bit it was a long process, but I was able to hide and show certain aspects of my scene and then see how that updated the try and verts count. I actually noticed that the really small, insignificant parts of my scene were just massive, massive poly counts. So I actually just got rid of a lot of small things such as vents and nails and stuff that really didn't need to have these massive poly counts. For example, this small plant had 4,176 faces, and it was used multiple times, a lot of times throughout the scene. That's a lot of faces. However, if you have a high poly model and you can't start again or remove it because it's important, there is something that you can do in Blender. Love Blender. So open up your FBX in Blender, and what I want you to do is find the decimate option. From here, you can then choose to unsubdivide, and this will work its magic and actually remove faces. Of course, it's going to change the shape of your model, so sometimes this means that the textures will no longer fit. But for small objects and simple objects that maybe only have a tiling texture, it could be okay. As a rule of thumb, if you didn't already know, it's really good to use a low poly mesh in your games and then get the high poly mesh with the detail and bake this into a normal map that you can then use over your low polys. It'll keep the nice crisp look, but it will keep the poly count down and performance good. You can also set up lodding, but honestly I don't know too much about that, so go and look for another video on that, but lodding is good. Number 5, draw call batching. Every time a model is drawn to the screen, you have to issue a draw call to the GPU. Another issue that I found with my meshes was that they were all individual instances of the same type of mesh. For instance, every chair was its own FBX when it could have just been duplicates of the same mesh. Because of this, they weren't set up for batching, because as it says on Unity's website, only game objects sharing the same material can be batched together. Therefore, if you want to achieve good batching, you should aim to share materials among as many different game objects as possible. We had done this initially because we had set up the whole environment within Maya and then just exported it all as one FBX, which then created unique instances for each of the parts of the FBX that were exported. This was to save time with setting up the environment within Unity itself. But now obviously I see the drawbacks to that, which is performance. It would add to the draw calls greatly because each mesh would be seen as a totally unique object instead of duplicates of one another, which they technically were. So to rectify this, I used one instance of the mesh and its material on all of its duplicates. I highly recommend that you go and do some research into batching because it's not quite as simple as one draw call per model. There are other factors that come into play here, such as per pixel lighting, shadows, and things like that. There are two main types of batching, and that is dynamic batching, which is for small enough meshes that transforms their vertices on the CPU, groups many similar vertices together, and draws them in one go. And there's also static batching, which combines static, unmoving game objects into big meshes and renders them in a faster way. You can go into your player settings to enable and disable these. They both do have their drawbacks as well, so please do research more into those. For example, with static batching, I did find out that the entire of the static batch meshes would be rendered even if just one aspect of that batch is seen by the camera, which means you could end up having more vertices than you need. 6. Occlusion culling. Told you we'd get there. Another issue that I ran into by having multiple meshes exported as one FBX was occlusion. Occlusion didn't work properly on those meshes because if one part was seen by the camera, then the rest of it was also going to be rendering. And occlusion is supposed to stop that. Occlusion is supposed to only render what the player can see within their camera viewport. For example, the floor was one whole FBX. And that meant that the floor was constantly being rendered, the whole floor, not just sections of it, bit by bit, the whole floor, even if the player was on the other side of the building. And to be fair, the floor and the ceiling didn't have too many vertices, but we also had the same issue with multiple objects, such as all of the cupboards were one FBX. So if one cupboard was being rendered by the camera, all of the cupboards throughout the whole building were being rendered. Now, I didn't have time to go in and fix all of that myself. However, setting up occlusion properly still very much helped my game. Within the static drop-down of a game object, you have two options, occlude static and occluder static. Occludees are game objects that can be culled, and I made everything occlude apart from my monster because that kept popping in and out of occlusion, and I needed the player to see that. But everything else was occludees. And then you had occluders, which are game objects that can help with the culling. It can occlude everything behind it. So this is great for large objects such as walls or doors that would never be opened, locked doors. Because one issue that I had was that the terrain was constantly being rendered because I hadn't set up my walls to be occluders. And when they were occluders, the terrain was no longer rendered when the player could not see them through a wall. I also set up occlusion areas to define view volumes in the occlusion culling system to basically tell the system where the player was most likely to be. For me, this was very simple because I was doing everything indoors and I have a very linear gameplay, so I could easily predict where the player was going to be. It's probably going to be harder in an open world game or something like that. At bake time, Unity generates higher precision data within the view volumes, and at runtime, Unity performs higher precision calculations when the camera's position is within a view volume. And if you don't specify a view volume, Unity will create you one that just encompasses all of your occludees and occluders. And as you can imagine, that would be massive. So you definitely do help save on performance if you set these up manually yourself. But like I say, if you have more of an open world, you might just have to let Unity do its thing. You can calculate the occlusion by going to Window and Occlusion Culling. Usually the default settings are perfectly fine, but you might want to play around with these just to get the effect that you'd like. Again, I'll put more details on occlusion in the description below. Number 7, light baking. Light baking was always something that I struggled to do within this game because it changed dynamically from day to night, which, as you can imagine, drastically changed the lighting within the scene. In hindsight now, I should have found a way to seamlessly transition to a new level that would have definitely helped performance, and there are a couple other things that I could do which I will tell you about now. So for now, I chose to use mixed lights and baked lights. Mixed lights are the best of both worlds, combining real-time lighting with some baked lighting as well, as long as global illumination is enabled within your scene. And then baked lights cannot change during runtime, but they significantly help to improve performance. Baked lights reduce the cost of rendering shadows as their light is pre-calculated. So I baked some default lights into my scene. However, it was a bit too light for the nighttime transition. Luckily, I had already set up a post-process effect that was put on the player when the nighttime happened, and I simply made this darker, so I faked it. Another possible avenue that I could have gone down for this was to create multiple different light maps, and then I could have switched out the light maps at runtime. Because every time you bake lights, you get a light map, and that's what your game uses. If you can get this light map and then switch it out using a script, then you can get different types of lights in the same scene. So that could have been perfect, but yeah, I didn't do that. I just think I ran out of patience, to be honest with you. I also used light probes to improve the quality of lighting on dynamic objects within my scene. Light probes are positions in the scene where light is measured during the bake, and then this information can be used during runtime to approximate indirect light values from the nearest light probe when it hits a dynamic game object. Overall, light baking is a very complex and useful tool, especially for improving your game's look and performance, and I will admit to not yet fully understanding it. However, I will put in the description a video about light maps that I found very informative. Number 8, optimizing your code. Ultimately, every script is different and there will be endless tips on how to optimize your C#. So I'll just focus on the main points. Surprise, surprise, the update. We spoke about this a little bit earlier, but I definitely need to talk to you about it in more detail. Every piece of code in the update gets run every single frame of your game. Hence why in the security camera script that I showed you earlier, I had multiple checks before running any logic that was put in my update. Putting code into the update without thinking about it is quite a rookie move, because when you first learn about it, it seems pretty logical. I mean, if you have code in the update and it's always running, then it's easier to debug whether it's working correctly, and you don't have to worry about whether it's going to be triggered or not. However, when optimizing, you really need to ask yourself, does this logic need to be ran every single frame? If it's the character movement, probably yes. If it's a door opening and closing, probably not. And if it is not, then think about whether it can be put in its own function that is triggered only when it's needed. Simply put, the less amount of code in the update, the more performant your scripts will be. For example, I had a script that was checking for certain actions to be done by the player. This would then increment an integer variable called observant. This check was being done in a separate script to the one that was managing the player interactions, and it was checking whether the player was inspecting every single frame. Whenever the player had inspected an object, it would then return true and then increment +1 to the observant integer number. There was no real need for this separate script to have logic in its update to check whether the player was interacting. To make this more performant, I made the observant variable global so that it could be easily accessed by other scripts. And then I simply added the increment logic into the interaction script itself, so that when a player interacted with something, it also then incremented that global observant integer variable. No more checks in the update were needed. It simply said player interacts, update this variable, and that was that. It's all about breaking down the logic and finding the most direct route to get the result that you need. If you need code to run frequently, but not necessarily all of the time, then perhaps look into coroutines. I use these for short-lasting events and animations such as lights flickering on and off, and also UI fading in and fading out in between screen loading times. However, they do have their own drawbacks, as they can be difficult to debug and they do create garbage. Again, I will put a link down to a wonderful blog all about updates and how to keep them performant in the description below. A function to look out for this time is find GameObject. I had used this function a lot when I was first starting out in game dev, and I thought I was really smart at the time. It saved me the time of having to manually assign all of the relationships between the assets because I could just get the game to do it for me, which is great, right? No. The game needs to be handling things that should run the game, not stuff that you should be manually setting up yourself. Come on, you lazy game dev. I ended up using find GameObject in so many of my scripts, and I had to slash it out and manually assign stuff because that helped performance. The game could then focus on running the game instead of finding everything and setting it up correctly, which I should have done beforehand. When you call this function, the game has to manually loop through all of the game objects that are currently in the scene to find the one that matches your name. That's potentially so many game objects, and as you can imagine, if you have this happening all at the same time over multiple scripts, it's definitely going to affect performance. To manually assign them, you can create a public variable and then select the appropriate game object or whatever that it is, and assign the correct one to it within the inspector. Manually assigning, though, will only work on game objects that are already in the scene. So if you're planning on spawning something during runtime, then you might need to use this, or perhaps use more specific versions of this. I know there is find game objects with tag and things like that, so that will probably be better to use than just the generic find game object. And if you're unsure whether you'll need them, then just put a check beforehand. Just see whether the relationship has already been established, and if not, then you can find the game object. I often did this with things like my camera, just in case for some reason I would lose reference to my camera because I was switching cameras quite often. So I would say, if camera equals null, then find the main camera. Lastly, turn off scripts when they're not needed. You can do this like I explained earlier with the collision. Collision's a great way, that's how I do it. It's probably not a great way. If you know a better way than to turn off things via collision, let me know, because I just had collisions everywhere saying, yeah, the player is nowhere near this thing, so turn it off and don't do all the things. So maybe you know a better way. Tell me, please. Number 9, optimize your game object components. Unity offers many components that define the behaviors of the game object, which really makes our lives so much easier. We don't have to code every tiny detail, which is great. Especially for physics. It's great. You simply select a game object and add a new component in the inspector window, and ta-da! Your game object now has physics, UI, collision, or so much more. So much variety. However, some of these components are way more performance expensive than others. So do make sure you're using the correct ones for your needs. Don't do what I did and just use mesh colliders on everything because it's so much easier. You lazy game dev. Oh man, this is just me berating my younger self now, isn't it? Mesh colliders have a much higher performance impact than box colliders or any other type of colliders, so really use them sparingly. It seems like the best collision to use because it will create collision that perfectly matches your geo. However, it will be checking for collision against potentially every single face of your mesh, which is probably not needed. If you need to create collision that does match a certain shape, maybe a rectangle or something, you can use multiple collisions. You can use 2 box collisions to create that right angle. Is that what I just said? Something like that. All you have to do is create multiple primitive collisions and then change their scale and location to create the collision shape that you need for your geo. And if you're anything like me, you'll get really excited about the thought of anything in your game having the ability to use physics, and you'll put rigid bodies everywhere when they're not needed. As you can imagine, rigid bodies use the inbuilt physics system that Unity has, and it does affect performance. It will definitely impact performance if you have a rigid body that is also using a mesh collider. which a lot of my game objects had that combination and it wasn't good. So I actually just removed all of the rigid bodies from my game apart from on moving objects such as the player and the monster. I had a misunderstanding of how the rigid body worked. I thought it needed to be put on anything that could be movable. And this isn't necessarily true because I had objects that could be examined and then they were brought up to the camera's face, and then the player could use their mouse to basically just turn it around, have a little look at it, look at all the details and nice things. That doesn't use physics. That doesn't need a rigid body. That was all done by script. So actually I could just remove all of these rigid bodies and it really did help save performance. 10. Adjustable quality settings. Finally, give the player some control over the game's performance themselves. Allow them to adjust the quality settings at runtime. You might be testing your game and it runs perfectly fine in your beastie gaming PC, but then if someone really wants to play your game and all they have is a crappy laptop that their dad bought them 5 years ago for Christmas, they have no way of changing the quality and trying to improve the performance, and then they can't enjoy your game. This is more simple than you might think. You can rename or add new quality settings under Edit, Project Settings, and Quality. All you have to do is create a drop-down menu in your game with the same amount of quality levels as what's in your project settings, and then call Set Quality Level on drop-down Value Changed. I watched this tutorial by Brackies. I'm sure a lot of you, if you watch a lot of game dev tutorials, will know who he is. Wonderful. Please watch that if you'd like to find out more about how to create a settings menu in Unity. Description down below, link down below in description. Okay, here's the bonus one for you. Number 11. There will be bugs, don't panic. When working with a game that wasn't built with performance or longevity in mind, there will come a time where fixing one bug will just start to create more. So when I began improving this game, I had grand visions of including new sections to it, new levels, adding new mechanics and features, and that simply just was not attainable. Even though I was able to add one new feature of a webcam and update some of the designs on certain aspects such as the doors, I had to ultimately abandon my hopes and dreams of including much more content to the game itself. And after I had worked my little butt off for 3 weeks updating this game's performance and released it, letting people know about it on social media, I then realized that there was a PC-specific game-breaking bug. And not gonna lie, I was so tired. I think I'd worked really hard, and then to find out that the game couldn't even be completed by some people was just a kind of kick in the face. To make matters worse, because it was PC specific, it didn't happen on my PC, so I had to give the potential fix builds to someone whose PC did have the bug. It took longer to do that one bug than to update the performance of the whole game. It was infuriating, but that is game development for you. It's a fickle process, but it is challenging and it is really rewarding. I can safely say that perfection is one of the most proudest achievements that I've had so far. And that is simply because game dev offers so much. It offers me so much to learn. It offers players so much to become immersed in. It's the only entertainment platform that can really engage with its audience in ways that no others can. And I find that really rewarding. But of course, game dev is huge. There's so many aspects to it. There's so much to learn. There's so much that I still don't know, and I'm sure there's so much that you don't know, especially if you clicked on this video. So let's learn together. That's also what I love about the game dev community. If there's something that I have missed out in this video that you know about, please write it in the comments. Or if there's something that you want to expand on that I have talked about, write it there too. Hey, if I'm wrong on something, call me out on that. There's still so much that I want to learn, And I just hope that by sharing what I learned along the way with you, that it will also help you in your game dev journey as well. With that all being said, please check out Perfection and check out the performance updates, all exciting stuff. Also some new features in there as well, some new content to check out. So I would love it if you could check out the game and just tell me what you think of it. Any feedback, good or bad, constructive, you know, just yes please, thank you. Okay. I don't know why I'm like so nervous now. Anyway, it's been nice to chat with you again. It's been a long time. I will see you very soon and have a lovely day or evening. Bye. Thank you so much to all my Patreons for all your support. I really appreciate you so much. Thanks to Dimitri Bart, Lee Clark, Lewis Frost, Gaming with Malachi 79, Zomalanovic, Mantaz Navakaz, Colin Williams, Ib196, Andy Bonte, Faraz Sayed, and Thomas Graham Jury. You are awesome.
Is he going to jump out at me? I want to escape. How do I go for... Ah! That's me. Oh, God.